Welcome to long-form content of Tech Bytes and News. This is a compilation on latest news and articles featured on Hacker News. You can find the original links of articles in the description. Please like and subscribe to support future content. Hope you enjoy.
Welcome to Tech Bytes and News, your daily roundup of articles featured in Hacker News. Today we're diving into a fascinating article from lwn.net about a novel approach to exposing concurrency bugs using a custom Linux scheduler. It's all about shaking those pesky bugs loose.
Sounds exciting. I'm particularly interested in how this custom scheduler differs from existing concurrency testing tools. Is it a completely new approach, or does it build upon existing techniques?
It's a clever blend of old and new. The core idea, introducing randomness into thread scheduling, isn't new. Many tools already do this. But this scheduler, Concurrency Fuzz Scheduler, uses the Linux kernel's sked_extadjet framework to achieve this in a unique way. It's not as fine-grained as some other tools, but that's its strength. It targets gross logic errors, the kind that often slip through the cracks in real-world applications.
So it's less about finding subtle memory model violations and more about uncovering those nasty, hard-to-reproduce bugs that plague developers? That's a huge problem.
Exactly. The article gives a great example: a producer-consumer queue with expiring items. A seemingly simple scenario, yet it highlights how seemingly innocuous pointer copying can lead to catastrophic failures under load. The scheduler deliberately introduces delays and randomizes thread execution to exacerbate these issues, making them much easier to surface.
I see. It's almost like a controlled chaos approach. But how does it actually work under the hood? The article mentions a global queue. Doesn't that create scalability issues?
You're right to point that out. The simplest implementation uses a global queue, which is great for demos, but it's a bottleneck on larger systems. The synchronization overhead between CPUs becomes a major performance drag, potentially even triggering the kernel's soft lockup detector and causing reboots. Yikes!
So it's not quite ready for prime time in production environments then? What are the limitations?
Currently, it's more suited for individual developers debugging intermittent issues on their workstations. It introduces significant performance overhead, running tasks much slower than usual. The developers acknowledge this and are working on improving performance and scalability. They're exploring things like local queues per CPU to alleviate the synchronization problem.
That makes sense. What about future directions? Are there any plans to make it more intelligent, perhaps by analyzing application memory?
Absolutely. The developers are considering adding more sophisticated features, such as allowing applications to provide scheduling hints. Imagine being able to preempt a task during a critical section. That would be incredibly powerful for catching synchronization bugs. They're also looking at simulating memory latency and other sources of erratic behavior to broaden its effectiveness.
This sounds like a really promising project. It's exciting to see how sked_extend is enabling more innovative approaches to concurrency testing. It's a testament to the power of open source collaboration too, with developers from OpenJDK and Meta working together.
Precisely. And that's a great point to wrap up. The Concurrency Fuzz Scheduler is a fantastic example of how open source tools can help us tackle the ever-increasing complexity of modern software. It's still early days, but the potential is enormous. Thanks for joining us on Tech Bytes and News. Have a great day.
Bye-bye.
Welcome to Tech Bytes and News, your daily roundup of articles featured in Hacker News. Today, we're diving deep into Google BigQuery's new pipe query syntax. It's a game changer, folks. Seriously.
I've heard whispers. What exactly makes it so revolutionary? Is it just syntactic sugar, or is there real power under the hood?
Oh, there's definitely real power. It's not just about making queries prettier. It's about fundamentally changing how we approach complex data manipulation. Think of it as a more intuitive, linear way to build your queries, step by step.
Step by step? Like a pipeline. That sounds efficient.
Exactly. You start with your base table, then chain together pipe operators, greater than each performing a specific transformation. Select, filter, aggregate, join. All in a clean sequential flow. No more nested subqueries or CTEs for every little thing.
So no more headaches trying to decipher deeply nested queries? That's a huge win for readability.
Absolutely. The order of operations is crystal clear. You build your query as you would think through the problem, making it much easier to understand, debug, and maintain. Even complex aggregations become straightforward.
But what about performance? Does this linear structure impact query execution time or cost?
That's a great question. Google assures us that pipe syntax queries are priced, executed, and optimized identically to their standard SQL equivalents, so no performance penalty whatsoever. You still need to follow best practices for cost estimation and query optimization, of course.
I see. Interesting. So what are some key differences from standard SQL syntax? Are there any limitations?
Sure. One big difference is that you can start a pipe syntax query directly with a from clause. Also, aggregation is handled by a dedicated aggregate pipe operator, not the select statement, and filtering is always done with a WAE operator, which can be applied at any stage of the pipeline.
Got it. And limitations. Are there any operations that pipe syntax doesn't support?
There are a couple. You can't use differential privacy clauses within a select statement after a pipe operator, and named windows aren't supported. But honestly, those are minor limitations compared to the overall benefits.
So what are some killer use cases? Where does this really shine?
Well, ad hoc analysis is a big one. Building queries incrementally, step by step, is incredibly efficient. Log analytics is another area where this shines. The linear structure is very intuitive for those familiar with other pipe-like syntaxes.
And what about those new pipe operators? Extend, set, drop, rename. They sound powerful.
They are. Extend lets you add computed columns, referencing previous aliases without repetition. SET lets you modify existing columns. Drop and rename do exactly what you'd expect. The aggregate operator is particularly slick, letting you group and order in a single clause.
This sounds incredibly promising. It seems like a significant improvement over standard SQL, especially for complex queries. It's almost like a paradigm shift in how we think about writing SQL.
Precisely. It's a more natural, intuitive way to express data transformations. It's still early days, but I'm incredibly excited about the potential of pipe syntax to revolutionize how we work with BigQuery. This is a huge step forward for data analysis.
I agree. Thanks for breaking this down for us. This is definitely something our listeners need to check out.
You're welcome. And that's all the time we have for today's Tech Bytes and News. Thanks for tuning in, and we'll see you next time. Goodbye.
Bye-bye.
Welcome to Tech Bytes and News, your daily roundup of articles featured in Hacker News. Today, we're diving deep into a fascinating study, learning fast and accurate absolute pitch judgment in adulthood. It challenges long-held beliefs about the critical period for developing absolute pitch.
Absolute pitch, huh? That's the ability to identify a note just by hearing it, right? I always thought that was something you either had or you didn't, something you had to develop as a child.
Exactly. The common wisdom, supported by decades of research, was that you needed a genetic predisposition and to start musical training before age 5. But this study throws a wrench into that idea. They found that adults can learn absolute pitch, achieving levels comparable to those with natural AP.
Wow, really? That's a pretty big claim. What kind of training are we talking about here? Was it some sort of intense, years-long program?
Not quite. It was an 8-week online program, totaling about 21 hours of training. They cleverly addressed some methodological flaws in previous studies. For example, previous studies often only focused on 1 or 2 octaves, but this one used 3, focusing on chroma rather than just pitch height. That's a key difference.
So they made sure they were testing the ability to recognize the quality of the note, not just its position on a scale? Clever.
Precisely. And they also eliminated external references during testing. No feedback, no sample tones, just pure, isolated notes. They even made sure that successive test tones were more than an octave apart to minimize the use of relative pitch strategies.
That's impressive. So what were the results? Did everyone become a perfect absolute pitch maestro?
Not everyone, but the results were striking. On average, participants showed a huge improvement. A 128% increase in accuracy and a 42% reduction in error. Amazing! Even more impressive, 2 participants achieved near-perfect accuracy and speed, comparable to natural absolute pitch possessors.
2 out of how many?
12. That's a significant portion of the participants. And the study addressed potential biases, like pre-existing abilities. Participants weren't screened for cognitive skills, and their initial absolute pitch performance was quite low. The improvement wasn't just due to chance either. They had to pass the final training level multiple times consecutively.
So this really does challenge the idea of a critical period for absolute pitch? That's a paradigm shift.
It certainly suggests that. The study's authors argue that the critical period might be better described as a sensitive period, where learning is easier early on, but it's not impossible later in life. There's still some debate, of course. Some might argue that the two top performers were outliers, but the overall improvement across the group is significant.
I see. It's a really interesting study. It makes you wonder what other skills we might be able to learn later in life than we previously thought. What about the limitations? Were there any?
Of course, the sample size was relatively small, and the training was done online, which introduced some challenges in monitoring participant behavior and ensuring the integrity of the tests. There's always room for further research, with larger samples and more controlled environments. But this study is a significant contribution nonetheless.
Definitely. It opens up a lot of exciting possibilities. Thanks for breaking this down for us.
My pleasure. And that's all the time we have for today's Tech Bytes and News. Thanks for listening, and we'll catch you next time. Goodbye.
Bye-bye.
Welcome to Tech Bytes and News, your daily roundup of articles featured in Hacker News. Today we're diving into the exciting evolution of LibreOffice, a true veteran in the open source world.
40 years old and still going strong. That's impressive. What's the secret sauce? What are the key advancements discussed in this article?
Precisely. The article highlights two major developments. First, real-time collaborative editing in LibreOffice Writer using conflict-free replicated data types, or CRDTs. Think Google Docs, but without the cloud dependency. It's all local, yet synced seamlessly.
Wow, local collaboration. That's a game changer. So no more battling version control nightmares?
Exactly. And that's not all. The second big thing is ZetaOffice, a WebAssembly version of LibreOffice. This means it runs directly in your browser, on any operating system, any CPU architecture. Think of the portability.
Hold on a second. WebAssembly? Isn't that, resource intensive? LibreOffice isn't exactly lightweight, right?
You're right, it's a hefty piece of software. The initial load is significant, a gigabyte or more, but the team is actively working on modularizing the code to improve performance and reduce memory footprint. It's still in beta, but the potential is huge.
I see. So ZetaOffice is like a browser-based LibreOffice, but with the option to run locally too? That's clever. What about scriptability?
That's where things get really interesting. ZetaOffice integrates beautifully with JavaScript. You can embed LibreOffice apps into web pages, control them via scripts, and even create custom UIs. The possibilities for web applications are endless.
That's incredibly powerful. Imagine building dynamic web apps with rich document editing capabilities, all powered by LibreOffice. It could really disrupt the market, especially for those seeking open source alternatives.
Absolutely. And the best part? All the code is under the MIT license, so it's completely open source. The development team is actively contributing their work back to the main LibreOffice project. It's a collaborative effort to make LibreOffice even better.
This is fantastic news for the open source community. It's a testament to the enduring power of LibreOffice and the innovative spirit of its developers. It's almost poetic, a 40-year-old software suite getting a major facelift and embracing cutting-edge technologies.
Indeed. It shows that even mature software can adapt and evolve, finding new ways to remain relevant and useful. It's a compelling example of how open source projects can thrive and innovate over decades. And that's all the time we have for today's Tech Bytes and News. Thanks for listening, and goodbye.
Bye-bye. Thank you for listening to the daily roundup of Tech Bytes and News. See you again tomorrow. Goodbye.